Hello everyone, and welcome to this video where we will be exploring the topic of creating our own lightweight microframework inspired by Express.js, Koa, and Oak. Now, when I say it's lightweight, I mean it. It does, however, include routing support for HTTP requests and even dynamic paths, as well as a simple way to start the server and handle incoming requests. So let's take a look at how this framework can be used from the eyes of a developer, so from us. So this code in the main TypeScript file represents how users would actually interact with that framework to build their own little server with some endpoints defined. First, you'll have access to a server object that allows you to specify the hostname and port. With this object, you can also define the routes that we want to handle in our REST service. You can see it's very straightforward. We specify which HTTP method we want to handle. Then we give the path for that handler. And finally, we give the actual handler method. The handler param gives us a context object, which contains the incoming request and the parameter variables for that request, if there's any. And it expects a promise response object. The next one showcases the usage of dynamic paths. We have this name variable, which we can reference in our handler by making use of the context object. We obviously support more than just get methods. We support post, put, delete as well. So here we have a post example where we get the JSON body of the request, parse it into a name object, which mainly just expects a name field. And then in the response, we just output back that name to us with status 200. After setting up the routes for our server, we can easily start it by just calling the start method on it, and it should launch our server. We can try it out in Postman. So here we have the root path. When we send a request, it returns hello world, which is what we're expecting here. We can try out the dynamic paths. So if we send name John, it should say hello John. If we change that to Johnny or Nick, it should say hello Nick. And finally, we also have our post. So if we change this to John Smith, hit enter, it should display that name. We also support 404s for whenever someone tries to specify a route that actually doesn't exist. So if we try one that doesn't exist, it should return not found with a 404 status. Let's set things up. We don't need to have anything other than Deno for this. And to start our project, let's create a directory called Deno Micro Framework. We can cd into that, and we can initialize our Deno project by typing Deno init. This will create a bunch of files for us. So let's open that in VS Code. Now in VS Code, we can delete everything except our main file. And let's just go ahead and clear that one up as well. And we should have an empty main TypeScript file and our Deno.json file. The main TypeScript file will behave as the user of our framework, similar to when you're creating your own application with Express. So let's create a framework folder to hold all our microframeworks code. We don't need too much to get something simple with routing up and running. First file will be the server Deno.Typescript file. This abstraction will allow us to focus on writing your application's core logic without worrying about the server setup. This will create our HTTP server, handle listening to connections, getting requests and responses to those requests. We'll start by exporting our server class. We'll create a few private fields. First will be our Deno listener. Afterwards, we'll also create the hostname as well as the port. We'll need a constructor to initialize these values. So we'll create one which takes in a host and port. So we initialize the host and port as well as the Deno listener. Afterwards, we'll create a async function called start. This will handle listening to connections. We'll first console something to show that the server is running properly. We'll be asynchronously iterating over the connections to avoid blocking other requests. And we'll call an async function which is called serve HTTP, which we'll create in a few seconds. And we'll pass that the connection. So serve HTTP is a private function which takes in a Deno connection. We first upgrade the connection into an HTTP connection using Deno's built-in serve HTTP method. Then we iterate over each request of this connection in an async manner, processing each part of the response as it becomes available without blocking the execution of other tasks. For now, we'll simply respond to the request by returning how's it going. Okay, this is enough for us to try it out in our main file. So I will hit save. If we head over to our main, we can first import our server that we just created. And we'll create a server object by passing in localhost and our port. In my case, I'm passing 8080. And then we can call the start function on our server. And that's all we need to start our server. If we hit save, go to our command prompt and start our server by running deno task dev and saying yes. We should see a console log saying that our server is running on host localhost and port 8080. So if we go to Postman and make a GET request, we should see how's it going. If I change that to a POST request, we should still see how's it going. Same as if I enter a random path, we should still see the same response. That's because we're not handling the HTTP method or the path. Everything going to localhost 8080, we're returning the exact same response. So, time to create our routing logic. First, we'll create a new file under our framework folder called routing.ts. This file will deal with mapping the paths and methods to the proper handler. We'll start by creating our context interface. This will contain the request object, which we get from the connection, as well as the parameters, which is a key value pair, and both keys and values are strings. Then we'll create a type to define what a handler is. Handlers are functions that execute when we create a certain route. It's the core business logic. We're saying here that a function takes a context object as argument and returns a promise of a response. If we look at our previous examples, we can see that these are the handlers being used, taking in a context object and returning a promise of a response. Next, we'll create the route interface. This will contain the path, the method, if it's a get, post, delete request, and our route handler. Now that interfaces are done, let's create our router class. This will have a list of routes, which will initialize to empty at first. We'll create a function that will add to this list of route. It will take the method, path, and handler and return nothing. And all it does is create a route object by passing in the method, path, and handler, and then just push this to the route list. We can make use of this function to create our public functions that will be specific to the HTTP methods. Our first one will be the get method. It'll take in the path and the handler, and then simply call the add route function by specifying that this is a get request. If we go back to our example, this server router exposes a router object, which we just created, which has a get function. This is how this function is called, and we pass in the path and our handler, and all it does is append this new route to a route list. This list will be used later for handling incoming requests and mapping them properly whenever we start our server. We can easily add support for other HTTP methods like post, put, and delete. These will behave exactly the same way, except for post, we're passing in a post string, put for put, delete for delete. Now have the logic to add routes to our server. We still need to use them when we handle requests. So let's create a handle request function. This will handle Deno request events asynchronously and return a promise of a response. To handle the incoming requests, we need a few pieces of information from it. Mainly, we'll need the method, which we can get from the request, and the URL, which we can also get from the request, but we're passing it into a URL object. This is because the request URL is a string, and passing it into a URL object makes it much easier to handle different parts of the URL. So if we want to access the path, the host, the port, we end up having fields for those. Next, we'll call a function, which we have not yet defined, called findMatchingRoute, where we would pass it the method and the path name of our URL. This would return a route or undefined. This would find if a method URL combination matches any of the routes in our routes list. If we have a match, we create our context object, which takes the request and params. For now, params will be empty. We'll deal with that in a bit. And we call the handler associated to that matched route, since you remember that a route object will contain the logic that we want. If nothing is matched, we return a 404 not found response. Now let's implement the findMatchingRoute method. This will be a private method that takes in two strings and returns a route or undefined. To find if a route matches our method or URL, we can use the find function on our routes list to iterate over each routes. URL paths use forward slashes to distinguish themselves. So let's split the one from the route. This will give us a list of strings. We do the same thing for the URL that we're looking for. We then check if their length is not equal, since if the size of the URL path segment that we're looking for is different than the current route, we know that they're not the same, so we can just return false. Otherwise, we know they're the same length, so we'll iterate over them. We can use the length of either one of them to iterate over both of them. So I'm just using the route path segment. We'll get the specific segment for each in that current iteration, and we'll check if they're equal or not. So if they're not equal, we'll return false. If we end up going through the for loop without ever returning false, it means that they're equal. So we end up checking if the method of that route is the same as the method that we're looking for, and we simply return the results of that. So now we can try this out in our main TypeScript file. I'll hit save. If we head over to our main, actually before we can test it out, we need to update our server TypeScript file, since there's nothing here giving us access to routes. So we'll first import the router that we just created. We'll create a router object. On initialization, this will create empty routes for us. And finally, we need to update our response. So instead of just returning a single response for all requests that we receive, we'll update that to call our router handle request function, which takes in the request event. And based off of that response, we'll respond to that event. So this will handle mapping everything for us. Now if we hit save, now we can go to our main and test it out. I'm gonna go ahead and paste a few routes here. So first we'll have a get route with the path of get me, which returns hello get. Then we'll have a post route with the path of post me, which returns hello post. Same for delete and put, they'll return hello delete, hello put. So let's try it in Postman. First, let's also start our server. Say yes. Now in Postman, we can try get me, and we should see hello get. If we try post me and try get request, we should see not found. And if we try post request, we should see hello post. Same for delete. You should see hello delete. Awesome. So great. So now let's add the final missing piece, which is adding support for dynamic params. So we're back into our router TypeScript file. If we go to the end, let's add a new function under find matching route. We'll call this one extract params, and it'll take two strings, the URL that we're looking for and the route path that it's associated with. It will return a key value pair. Both key and value are strings. First, we create an empty param. Then we do the same trick that we did previously, where we split all the path based off of their forward slash. Then we can iterate over their length. We're assuming that they're both the exact same length because they should only be called when find matching route returned an actual route. So when we're mapping over them, we'll take in the route segment first, which is the one we're mainly interested in, since that's the one that will contain the colon whatever string, which indicates a dynamic route. So this is the one that would have this, something like this. So we'll check, does it start with a colon? If it is, then we found a dynamic path. In this case, let's remove the colon since we just want the variable name. Then we'll take the corresponding URL path segment. So if we have a route like this, the route segment slice would remove the colon and would end up just keeping name, and the URL path segment would try and match get me / Jack. So that will return Jack for us. So now that we have the key and the value, we just want to add it to our key value pair. And then we can finally return our params. And we'll make use of it here by replacing our empty params with the extract params function by passing in the URL path and the matching route path. We also need to update the matching route, since for dynamic path, we will never actually return a route based off of recurrent logic, because if we're looking for a get me with a dynamic path, this will never equal whatever we set up in our route. Since we're setting up a variable here with a colon, but we're not expecting the exact same thing here. So we need to take this into account. It's pretty simple. All we need to do is right before us checking if they're equal or not, we'll just check if the route segment starts with a colon. If it does, we'll just skip this entire iteration, since it's a dynamic path and there's no point in us checking if they're equal or not. So we could then just move forward to the next one. Great. So let's give this a try. So we already have here a dynamic path. Let's change this. All right, let's give this a try. I'll refresh everything. Go to Postman. Now if we call get me Jack, hopefully we should see hello Jack. And it works. If we change it to J Mike, it should be J Mike. This completes our simple micro framework where we learned how to start our own HTTP server, get requests, mapping them to the appropriate route, have it execute its own logic, and handling dynamic paths. Thanks for watching. Bye.